So this section of videos is going to mostly focus on inverse trig functions. And in order to do that, let me real quick remind you guys of something called the horizontal line test. And as you may be able to figure out from the name, it is a test that involves horizontal lines. So what you do is on the graph of your equation, you want to draw a bunch of horizontal lines. And you know that you pass if all of these lines hit the graph 1 or less times. So 1 or 0 times is acceptable. As soon as you hit twice, then it no longer passes. So let's take a look at the graph of sine and see if that passes the horizontal line test. As we go through here, we're going to draw a few horizontal lines. Forgive my poor straightness. But you can see that it hits 1, 2, 3 times for each of these lines. And really, if you think about it, this is the graph of sine. It goes on forever and ever and ever. So really, it hits infinite amount of times. So in order to rectify that and make sure that we've got that inverse, what we can do is restrict the domain of this function. And as we mentioned, this should go on forever and ever and ever. But what I did by grabbing this little section is I've restricted it from only between negative 3 pi over 2 and positive 3 pi over 2. So I've gone from infinite times hitting the line to only 3. And if we take that idea, we can restrict the domain even further to make it so that we do only hit 1 time. So I'm going to take a moment and erase all this. Now as we restrict this domain, we need to make sure that we're not cutting off any of the range of the function. So our goal is to restrict this domain so we pass the horizontal line test, but also so that we can get every y value that's available from negative 1 to 1. If you wrote down the range of this function, you would write it down as from negative 1 to 1, because that's the lowest y value, there's the highest y value. So let's go ahead and look at different ways we could restrict this domain. The first way we could restrict it is if we cut it off here, because that's the highest y value, and if we go down to the lowest y value, this would be an acceptable way to cut off that domain. Restrict it so that we have that inverse function. But some other people might notice, well, you could also go from there to there, from the lowest y value to the highest y value. And again, even on just this picture, we could go from the highest to the lowest there. So any of these three are acceptable ways of cutting that domain. And mathematicians realized that there are infinite ways to cut that domain down, so they said, let's just agree on one. Well, they knocked out this one because it involves a lot of negative numbers. And if we can, we're going to try and avoid negative numbers. Then we looked at the remaining two here, and we said, well, let's try and avoid big numbers. So they cut off this right here, which leaves us with this domain restriction between negative pi over 2 and positive pi over 2. That's how we're going to cut that domain so we get that invertible function. So our domain restriction for sine of x is going to be, now let's go ahead and write it in this notation, negative pi over 2 all the way to pi over 2. So that's that domain restriction we apply in order to get an invertible sine function. Now sine isn't the only one, so let's go ahead and do the same thing for all of our other remaining 5 trig functions. If we look at cosine, again our range is going to be from negative 1 to positive 1. So we can restrict ourselves to anywhere from there to there, or from there to there, or as we extend the graph, we can again continue on forever and ever and ever. But these are the two that we're going to mainly look at right now, because all those other ones are going to give us really big numbers. So again, mathematicians said, let's choose one of these to be the main restrictions there. Again, not a huge fan of negative numbers, so which leaves us with this one here, from 0 to pi. So our domain restriction for this guy is going to be from 0 to pi, because as we cut from 0 to pi, we'll get all possible y values, and we'll pass that horizontal line test. That is that domain restriction for cosine in order to give us that invertible function. Next up is going to be the graph of tangent, and again, it looks a little bit weird if you've seen it before, but don't get too freaked out about it. The main thing to remember on this is that there are asymptotes on this graph. So right here, you've got an asymptote, which means if we were to zoom out and see, this line will get really, really, really close to this vertical line I just drew, but never actually touch. And then as soon as you cross over that line, you'll end up popping back down to here, and it'll continue up and up and up and up, and then it'll eventually reach here, which is another asymptote. And then we've got another asymptote right here, so we've got a lot of asymptotes going through this graph. So which means our range for this graph is negative infinity all the way to positive infinity. That'll give us all those y values. And it turns out tangent's really nice because it actually already broke itself off into different domain restrictions for us. All we have to do is choose one of these little s's to choose as our domain restrictions. And the nicest one that I can see is this one right smack dab in the middle, from negative pi over 2 to positive pi over 2. Now again, these are asymptotes. So while this might look exactly like the domain restrictions for sine, there's a little difference to it. Negative pi over 2 and positive pi over 2 are not included in these domain restrictions. So the domain restriction for tangent is actually with parentheses instead of brackets. Remember, your brackets are going to be what's included on that. So from negative pi over 2 to positive pi over 2. Here's our domain restrictions for tangent. And that's all wonderful, but what about the reciprocals? Well, cosecant, again, looks a little bit weird, but we've got those asymptotes again, except this time we've got it at negative pi, we've got it at 0, we've got it at pi. Now this is a little bit weird because some people would assume that you would just grab from 0 to pi. But convention says that we're actually going to choose something extremely similar to its original function, which is sine. So the domain of sine was from negative pi over 2 to positive pi over 2. And we want to keep that exact same domain restriction if possible. So when we do our domain restriction for cosecant, it's going to be from negative pi over 2 all the way until 0. Well, we can't choose 0 because it's an undefined point, so that's an asymptote. So we say 0, and then we're going to combine it with 0 all the way to pi over 2. So basically what's that saying is we're going to choose everything from negative pi over 2 to positive pi over 2, but we're going to neglect 0. 0 is not included inside of that domain restriction, just so that we don't include that asymptote because no point exists on there. Let's take a look at secant. Again, we're going to do that exact same thing with secant. The domain for cosine was from 0 to pi, so we want to try and keep that exact same one for secant, which means that we're going to end up going with a domain restriction of 0 to pi over 2, because this is where we get that asymptote on this graph, where pi over 2 is not included, and then join it with pi over 2 to pi. So again, this says we've got that exact same domain restriction from cosine, from 0 to pi. But this time we want to not include that pi over 2 because we create an asymptote there. So the very last graph we got to look at is cotangent. And cotangent, again, looks very similar to tangent, just almost looks like a reflection, kind of. So let's go ahead and look. This is the one that's different. So all of the other reciprocals followed their original. But for tangent, the original was negative pi over 2 to positive pi over 2. For some reason, we decided that the domain restriction would be its own little thing. We're actually going to go from 0 to pi for cotangent. So we decided that those domain restrictions for cotangent are going to be from 0, and because we're at an asymptote, it's not included, to pi, And again, we're at an asymptote, so it's not included. So I know we just went over a lot of different things here. So let me take a second and review all of those domain restrictions in order to get those inverses. So brand new page here. This is kind of the overall idea of this whole video here. The idea is, depending on which trig function you're looking at, so here's your function, and then here's the domain restriction that we're going to use in order to get that inverse trig function. So the first function we're going to look at is sine. If you have y equals the sine of x, then your restriction in order to get that inverse was from negative pi over 2 to positive pi over 2. The next one is y equals cosine of x. This restriction here is going to be from 0 to pi. For y equals the tangent of x, you've got the same thing as sine, except now you've got parentheses to show you that it is not included inside of those restrictions, because that's where you find those asymptotes. Then you have the reciprocal of sine, which is cosecant. And again, it's going to follow the same idea here. The only difference is now you cannot include that 0, because at 0 you get an asymptote. So we're going to go ahead and do negative pi over 2 until we reach 0, and then combine it with 0 to positive pi over 2. Next up is the reciprocal of cosine, which is secant. And this one again is very similar to the cosine one, except now we cannot include positive pi over 2 because that will give us an asymptote. So we say not included and then join it with everything from pi over 2 not included all the way to pi. Last but certainly not least, this is the real one that trips people up because it's the only reciprocal that doesn't follow the original's restrictions. So here we're going to restrict that domain to go from, it's not included, from 0 to pi. So the short version of this is memorize these domain restrictions here. Let me do that in another color so it's not messing it up. These domain restrictions here are important. If you remember these domain restrictions, then the reciprocals always follow. The only difference is this cotangent and tangent. Everything else, you're essentially looking at the exact same domain restrictions.